Okay, let me just get back to our slides here. So what we're talking about today is we were talking about we're using a new software here. And the new software is going to be called, it's rStudio. And rStudio is actually a very decent program when it comes to working with analytics. And so I hope that you've had some time here to install rStudio and first install rStatistic. And then once you've installed that, then you should be able to install everything else. It's actually not a very difficult program to make your way around. There are worse programs, in my opinion, for analytics, but I think that actually this is a pretty good one in terms of like, facility and online help and all of that good stuff. So let me start up my terminal here just before anything crazy happens. I just need to make sure this is going to come up on my screen, otherwise you're not going to see it, and that could be a waste of your time. So there we go, we've got that working out. Now, let's go back to the slides here. So what we're talking about in the slides are we're starting to visualize things here. And so I think where we left off, by the way, don't forget these links are very, very important here in the slides. So if you want to install a local copy of rStudio, then I encourage you to do so. And the thing is, though, that we can use Docker in this course. I gave you two different ways of actually running rStudio. Let me just make this point here. You can use Docker, or you can install rStudio locally. Now, I would recommend that you install rStudio locally just because it's a good program to have. But that means that you also have to have a bunch of space so that you can install that and the R programming language here. And so you have to think about how much space you have on your computer here before you install these things. But I think that the installers, though, will tell you that you have this much time to install things, or this much space you have to install things, and so therefore it should be relatively painless. It should warn you. So you have that, and then you also have the Docker container. Now, one of the points that I made was that when you use the Docker container, this tends to be a more updated version of rStudio. That means that the libraries tend to be more recent than if you install them this way, if you use the client here, the client on your local machine. And so I use both. I know that sounds a little bit excessive here, but I use both because sometimes the libraries that I'm trying to work with, they may only work when I'm working with a Docker container because they're just so new that that's just the best way that I can do it. But after a while, though, those libraries tend to make their way to the rStudio client that you would install on your machine, and then you'll have this message that will come up on your machine saying there's an update ready for you to install, and then when you do that, then those libraries will come over. So you have two different ways of using rStudio, and it's up to you how you want to compute, and I think that they're both very good ways of computing here. We talked about some of the how to get around. Well, this isn't really rStudio here. This is just the R programming language, and so we were talking about how to actually get on to use the R programming language here, and you can see that, for instance, there are some quite simple-looking. Well, it's not really so simple, but you can do some simple math on here, and that actually makes things very, very easy. When you're working with, when you have a program like this where you can just type in numbers and you can do what I call the back of the envelope types of calculations. So it tends to make math, working math or working computations very, very simple here. We talked about how you can use different types of variable names here. So here I was just defining a variable with x equals 1, or I have this arrow type of fixture where I have x with this arrow pointing to 1. In rStatistic, they tend to use this system of defining their variables, whether it's a string, whether it's a float, or an int, it doesn't seem to matter. You can see that there's two different ways of doing this, but I would advise using this method here with this arrow, just because it appears that that's going to be that's what the rest of the community is going to be using. I hope that for people at home here, I'm looking at our screen here. I have an overhead of the screen here. I'm trying to. Oh, okay. So I'm just trying to get the slides on our screen so that we don't have a bar that's interrupting our slides here. Hopefully you can. I'll move out a bit. Maybe you can see this a bit better. If you're having trouble seeing the slides here, please let me know. Otherwise, what I see on my screen and what goes on the screen overhead and what you see at home may be entirely different things, which is really, really crazy. So anyway, we were just playing around with this, though. We didn't do anything, any crazy calculations, but we're just playing around with kind of the general notions of how you can get around rStatistic and define your variables. which is actually a very big part. And then we talked about the Boolean logic. If you've taken discrete structures, that's CS102, we spent a lot of time talking about truth tables here. And truth tables are basically these mixtures of trues and falses. And there's a logical kind of calculation, if you will, on computing these truth tables here. And so you can always create truth tables using rStudio if you want, where you have, for instance, something like this where false and false, that's equal to false. If you have true and false, that's still false. If you have true and true, then that's true. And so you have these axioms of logical mathematics. If you were a logician, then you would be you probably use your R primarily with these kinds of functions in there. But if you're interested in learning more about truth tables and De Morgan's laws, where you're using Boolean logic to calculate things, then I invite you to read these or to go to these Wikipedia pages, which I think are actually quite good, to kind of explore more about what you can do with these kinds of functions here. In computer science, you tend to use these things to manage when you should be leaving or entering an algorithm, and so they do have other types of functions than just this esoteric theoretical stuff here. So they do have applied applications here. Then we talked about defining strings, which is exactly the same way as we defined variables here, but this time, instead of having a number, we had a string, and that means this thing in quotes here. And so if you have seen strings before in computer science, then I do apologize for repeating all this stuff here. I'm really speaking to the people who perhaps have never seen a computer programming language up close before, or if they have, perhaps they haven't seen what a string looks like. So I do hope you excuse me. So this is how you define a string, and a string is a kind of a group of characters put end to end, which creates a word. And so you define your words in this case with these quotes. And then we have these functions that we talk about, where this is called the paste function, which really just takes two different strings and joins them together, just as you see in this grayed out text below here. So first I describe my first name here, or I assign my first name here, which is Sherlock. I should have used, actually for this, I should have used quotes in this thing here, but that's okay, it doesn't matter. If you're doing this at home, you have to put Sherlock in quotes and Holmes in quotes too. That's a typo on my part, I'm sorry about that. But when I use this paste command here, it puts the names together. Okay, I think we're getting to the end of where we were. We were talking about this sequence command here and the summation, which is actually there's a lot of, I know this is just a few characters of code that you have to type in here, but actually to write a piece of code that does this and that makes a sequence here, where it really just makes an array of 0 to whatever number you specify, there's actually a lot of code involved in that. I mean, a lot. I mean, it's probably about 3 lines of code. And so, or maybe even less than that. But if you're wanting to do this and to make a sequence here, then having a simple command like this makes everything so much more easy. And I think that's really what categorizes rStudio over perhaps Python, in that you have many built-in functions which make everything very, very simple. Just to, if you're doing some quick math here, and you need a sequence, or you need this, or you need that, something that you might spend maybe 5 to 10 minutes perhaps coding. Well, in this case, in R, chances are you have a built-in function that will just do that for you, and so it makes everything very, very simple. Of course, you can always type up these sequences on your own, or you can create your own code to do this, but it makes everything nice to have it kind of built in as a function here. And the same thing that with the sum here, the summation just takes whatever you give it inside the parentheses, whatever numbers you give it, and then it will just add everything together. And once you have that added, it'll just take that, it'll just return the numbers of that addition to you, which is actually quite a useful thing here, because when you are working with some of your data, for instance, if you're computing, I don't know, maybe frequencies or something, sometimes you need to know what the whole summation is of some group, and then you have to figure out like the partial over the whole, and so you use something like this. Anyway, in this class though, we will go through seemingly all of these functions again and again and again. But for now though, I want you to be aware that there are many built-in functions that make your coding much, much more simple than if you had to like code everything yourself and write your own script to make everything happen. And so that's really why I think that R is an exceptional language. I don't know that we had time to go through all of this. Perhaps we didn't. Actually, I think we did. This is a very basic plot command here. This is as basic as they get. I like this though because when you're using plot, it's just one function and it's built in, and whatever you put inside this thing for x is what gets plotted. Now, if you wanted to write a plotting function in Python, now this is not, I'm not trying to like separate and and kind of like destroy Python here, but if you wanted to write a Python program to plot, it's a little bit more involved than just writing one word. You have to load a library and some other things, and then you have to write the code that makes it all come together. And so while that's all very, very possible to do, whoops, I don't know what just happened. Uh-oh. While you can do all that, you can, in R, for instance, you just have this one command here. Now, in this class, we are going to be writing some more involved plotting commands here, and I think that you'll see that your plots can actually be much more exciting than this. So this is where we left off. Now, one thing I would like to say, though, is that if you're using R, one thing I'll just show you here, to get out of R, you have to type in this Q open and close parentheses. Now, this is really not what I would say. Oh, gosh, I'm so sorry, guys. You can't see the screen here. I don't know why this. For some reason, each time I sit down with this machine at this particular post here, it seems like it doesn't quite, everything doesn't quite fit inside. Are you, for everyone at home, when you look at your screen, is that what you see? Is everything like off the marker here? Is it slightly off? I mean, do you see the whole slide at once here? Because what I see and what I see up there are, I don't know why. See, that's too close. I'm sorry, guys, at home here. I just have to do this way. It could be that our projector is acting up as it tends to do. I think I might just. Oh, that doesn't help. That doesn't help either. I'm going to leave it here. I'm going to have to kind of like wobble around between these different slides here. And so, if you're at home, or if you're in the classroom, even, please load up your slides here so that you can actually look at these slides here. I'm thinking that the screen that you see on your thing here. It's really me pointing things out, but you can actually read your slides maybe more easily if you have the slides actually opened. So that brings us up to today. So what are we doing today then? Well, today we're talking about visualization here. One of the most important things I would say in analytics is the ability to take massive amounts of data and to visualize them. And in terms of visualizing data, what that means is that you're taking some kind of some barrage of numbers, and you're making it have some kind of visual aesthetic. You're adding some kind of ability to see something that perhaps you wouldn't see if that data were just in numbers. And so the whole point of data analytics, I think, is to make decisions about things, and being able to see the trends in your data, I think, is absolutely fundamental to data analytics. And so this is kind of the overall. If you see your slides here, explore the world or the data of your world. This graphic that we have down here is really kind of how you do data analytics with rStudio here, or rStudio. And that is that, for instance, you take your data, you would import your data, and I have the number. I have some information below here, so you can see this. But you're taking your data and you're bringing it into your analysis area. I see your analysis space. That could be like your programming, or you're bringing the data from somewhere, from some real world place, and you're getting to work on it. Now, the data that you bring in is going to be raw. That means that it's not arranged in any particular way. It's probably arranged as it was collected. It's not going to be organized and easy for you to use just yet, and so you have to spend some time kind of organizing it in some way so that your code can actually pick this up and start working with it. And so they call that tidying your data, or kind of like, or they also call it wrangling. Wrangling is where you have the data and you're like putting it into columns, or maybe you're putting it into a spreadsheet, or you're organizing it by some specific means or something. You're doing something with it so that you can actually work with it. So that you're making the numbers actually numbers, and the strings are actually strings. You don't have numbers which have quotes on them. It's like you're doing the little work, the little pieces here and there to create a workable data set. And then you have to transform the data into something here. And transforming the data means you may have to use a model. You may have to use some kind of a new approach, or maybe it's your strategy and your analysis. We'll talk about that. But the transformation, though, is you're taking the data from this kind of mixed, or not this mixed bag, but it's still kind of, it's untreated. And then you're doing something with it so that you can, in this case, you can visualize it. And that means you're basically, in this case, transformation means putting our data into some kind of automated code. And so then we can visualize our data. And by that, I'm saying that we have run some kind of a model, as you see there. You have maybe put the data through some kind of a filtration system where you've removed the noise, and then you visualize it again, and then maybe your model helps you to remove that noise. And so that's really what analysis is all about, just transferring your data, putting it into some kind of a system here where you can analyze it, getting some visualization. Does the visualization account for anything? If it does, then keep going there, but if it doesn't, then tweak your model and then go back and forth and keep on going around and around until you actually have something that you can work with. And then at the very end of this thing here, you'll notice that there's this word communicate. Communicate is actually, I would say, probably more important than any of the other pieces on this analysis, on this graph here. Because if you don't communicate what you found, then it means that nobody knows anything about the work that you've done, and that means that everything you have done is in vain. And so the communication part is there so that you can help people to make decisions, or you can make decisions yourself, or you can tell your board members what the company should be doing now, because you have data to say that this is the way we should be moving and not that way. And so the communications part is actually very, very important. And communications will be done primarily with visuals. You'll use lots of plots. You'll use scatter plots. You'll use histograms. You'll use heat maps. There's going to be lots of plots in there because you can't expect people to understand what's going on by looking at a bunch of numbers. It's just not going to happen. And so keep in mind this whole system here. That's really what this class is talking about. This system up here, in that you are taking numbers, creating them into something that you can work with, changing them in some automated sense here, visualizing it. Maybe you're creating a model to make that visualization more precise, and then you're telling people, or you're writing up your results, you're somehow communicating what you found. And that is absolutely essential to the communication part here, because otherwise no one will know what you found. And sometimes the results that you find are actually quite significant. They might actually change the world. We just don't know yet. Anyway, we're going to be using a package here. This is a library in R, which is going to be called Tidyverse. I think that Tidyverse is actually quite good because it's, oops, oh gosh, not again. Maybe I can leave it like this. Maybe that's better. We'll be using Tidyverse. Tidyverse is actually a collection of a bunch of different types of packages which are available in R. This was put together by the authors of our book. And what it does is it allows us to do some data wrangling, plotting, basic model growth, and some other things, and it's all tied up into one package. Now, I think that Tidyverse, when you use the Docker rStudio container, I believe that Tidyverse as a library is already loaded. But if it isn't, then we'll load it ourselves, and I'll show you how to do that. So what I'm going to do is I'd like to take you through an example here where we're going to be talking about Sunspot Data. And so you may have noticed that when you pulled over your repository here, you found that there was some files in a Sandbox. And one of the files was called Sunspot, I think. And so I'd like you now to go to your directory, your Sunspot there, and click on your file. And I think that this is, that's not the file here. Let's go to the other one here. I'm going to open my file and find, hang on a second, where is my file? But load up your rStudio here, and then, or actually just look, if you can see the file, and you can right click on the file and say open with rStudio if you have rStudio installed locally. I'm assuming that everyone's installed their rStudio locally here. Okay, I'll just assume that. I'm just loading my file now here, so just give me a minute here just to find it. There are so many things that are, so many files I have to go through. It's just extraordinary. Okay, so the Sunspots that I have a Sunspot repository or directory here, and this is what I see in my Sunspot here. You should see similar code. Hopefully you do. How can I make this so that all of this stuff can fit on the same screen? Let me just work on this for a second while you do that. Trying to get this to sit inside here a little bit. Hopefully that works. Okay. Maybe that works. Is that all on one screen? Yeah, more or less. It's kind of there. You can kind of see what it's getting on about. All right. I'm just trying to squash this up a little bit here so that I can get everything into the screen. There we are. Maybe that'll do it. Okay, I think that's good enough. Okay, so this is going to be what you see when you log into your RStudio, and I'm going to just increase the size just a little bit here so that you can see what it is that I'm doing. Maybe I'll put this at 14. Hopefully that'll work. There we are. It's a bit more blown up here. You have less screen to use, but that's okay. I think that's this as well. Now, we're going to be loading this. So this code that you have here, hopefully you all have this code loaded here. If you don't have this code, please let me know here. Just go ahead and unmute yourself and just tell me that if you're having trouble here, and then I can go back and I can help you find your way through this. But I'm going to assume.
Professor?
Yes, sir.
Are we supposed to open the .r file?
Yes, you are. Yes, you are. So it's the sunspots.r. If you right-click on that file, it should allow you, in some cases, I guess, if you've installed this locally, to open the file with RStudio.
Okay. All right. Thank you.
Is that working? Is there anybody else who's having any trouble out there? If anyone's having trouble, then please let me know. But otherwise, I think it's just, yeah. I'd like to say that you can. Sometimes I won't see your chats here just because I have all these windows covering things up. And so please do just unmute your microphone and just ask your question. And otherwise, I may not get to it in time. So please let me know. Okay, so I'm going to go back to my RStudio now, and we're going to see where's that now? It's right here. Okay, so the first line that we have here is we're going to, first of all, we have to load this library, and I hope you can see where I am now. But this is called your Tidyverse Library. Now, to actually load this thing here, you're going to run this command here where you click on, you hit library here, and then if you can see in the, I don't know if you can see where my mouse is, but basically there's a button here that says run. I can't see that. It's if you, I'll just show you where it is. It's basically right here, if you can see that. I'm trying to find that. I'm trying to put the, oops. Sorry. It's basically, if you look at, if you treat this as a kind of an arrow here, your run is going to be right at the top here. So if it's fine, see the A where I am here? It's right above, there's that button run. So you want to click on run and run this thing here. And so this, if Tidyverse is installed, then you should have all this stuff come up here. But I'm thinking that in most cases, Tidyverse will not be installed on your machine here. And so what you're going to have to do is you're going to have to install this yourself. And to do that, your code is going to be modified by this. You're going to be typing in install packages, like this, and then inside quotes, you type in Tidyverse. Okay, and so when I'll just go ahead and run this and see what happens here. So I'm up here now. So when I click on run, oops, you have to actually select your line here and then run this. Oops. There we go. Yes. One of the things about R though is that when you run programs in this sense here, you run line by line. You don't run the whole program at once. You only run the stuff that you select. And that's done so that you don't get ahead of yourself. You might have a whole block of code that creates the, it makes a plot, and then you have another block of code after that that makes another plot, and then another plot, and then another plot. And so you don't want to run those all at once. Instead, what you want to do is you want to run the first plot, get that plot out, and maybe save it and do something with it, or look at it at least. And then you want to go into the next thing here. And so when you are running your code here, you have to select that code like this, and then you can click on the Run button here. Is anyone having any trouble with the install packages?
Yeah, I'm completely lost.
How are you lost?
Like,
what we're doing here is, okay, so in order to use this library here, you have to first install it. So this install packages here. If you don't have the library installed on your machine, then what you want to do is you want to type in this command install packages, and then select the whole thing like this. Okay, just select it, and then you click on the Run button. Or equally, you could type everything down here. Like that. You can type it down here if you want, and then that's the same thing, and then just push enter, and then it's going to install the package. Now, you only need to do this once. Each time you run this, if you run this code before, if you run this program before, or RStudio before, each time you install a package, it's saved locally, and so you don't have to worry about, it's not going to, you don't have to install it each time you run this code. And so what I tend to do is I leave that line of code there, but I put this hashtag in front of it like this, and that comments the whole thing out. So what we're doing here is we're trying to, in order to run this code here, you have to have this library present. And so this line of code above it actually installs that library, and you only do that once. So whoever it was who asked, does that help if you just type in install packages? Is anyone here having any trouble with the installing the package? It should come through. If it's not working up here, then just go ahead and type it down here in your terminal console space here, and you should be able to install that library. And then the next thing, once the library is installed, then it sits around in the computer's cache, and so you can access this. You can access this until you erase or uninstall the library. So it should be there forever, which is sometimes good, unless you want to update things. Is anyone having any trouble getting the library to install? Okay. Well, I'm going to move on to the next thing now. I'm going to assume that everything's okay and that everything's installed. I'm going to just go ahead and I'm on the same line as library here, and I think I can just click Run, and there we are. So wherever my cursor is, that's the line that I can see. I'm going to remove this. And so when I ran my library, this code that I see down here says that it's opening the library, and the library is, I should say what the library is. A library is actually pieces of code that allow you to do extra functionality, to have extra functionalities that you wouldn't normally have in your R programming here. And so this tidyverse gives us the functionality of plotting and doing some other cool things. And so that's why we have to use this. Otherwise, our statistic on its own, or RStudio on its own, doesn't have this functionality. So we have to actually bring that functionality into the code, and that's why we have to load a library. Now, the next thing I'm going to do here is I'm going to find the sun data here. That's the Sunspot data. And I'll just hit Run here. And then you can't see this, but actually a panel has just popped up on my screen, which is now asking me to go and hunt for the file that is in my repository. So I'm clicking through, I'm finding my repository, I'm finding my Sandbox, and I'm finding inside the SunSpots repository this file called Sunspots CSV. That's a comma-separated variables file which has the Sunspot data. Now, while this is happening here, let me just go back to the slides for a moment here and just tell you why we're doing this. What are we expecting to see here? What is this thing? So this is data which concerns the number of sunspots on the sun. Now, sunspots are actually these dark areas that you can see seemingly with the naked eye, although I'd say do not use your naked eye to look at the sun. But these are these spots that appear on the sun, which really represent areas of the sun which are cool. They're cooler areas. And so these are some pictures of sunspots here. And by the way, has anyone noticed that there's an orange actually in the picture? You've got to see everything. You've got to see everything. When you look at your data, you have to look at everything. Scrutinize everything here. I put Easter eggs in my slides here. But still, these are sunspots, and they are, the reason why we care about sunspots is because when you have more and more sunspots on the sun, it does interfere with radio communications here on Earth. It interferes with the weather patterns. It has a lot of, and then when you interfere with weather patterns on Earth, you're interfering with drought, and you're creating, strange living conditions. Now, it was thought for some time that these sunspots have what they call an 11-year period, which means that for 11 years, or for 5 of those years out of each period, the sunspots are coming up and up. There's getting more and more sunspots year after year for 5 years, and then after 5 years, you begin to get fewer and fewer, and then for the next 5 years, you get more and more sunspots coming up and then going down. And it seems like every 11 years, you see this kind of this rise and fall of sunspots. And they also notice that every 11 years, you have droughts, and you have problems with crops, and you have other problems with weather, or you have these enormous hurricanes, and you have other kinds of things that are going on, which could have something to do with the sunspots. But also, when sunspots are at their highest, your radio broadcasting is really kind of, it's put at a real disadvantage here, and you tend to find that there's a whole lot of problems with with just broadcasting signals. There's a lot of radioactivity up there from these sunspots, and that interferes with broadcasting here on Earth. And so what we're going to be doing now is we're going to be asking ourselves the question about, is there something predictable about sunspot data? In other words, can we look at sunspot data and see if there's some pattern? Could we use sunspots to explain any of this stuff that we have on the ground here? Is there some pattern that we can use to explain, for instance, our broadcasting difficulties, or our strange periods of weather here, or weather patterns here? We can't explain any of this stuff with the data. We have to go into the data, or we have to go actually to the source and study the sunspots. But the data, though, can give us some idea of whether, for instance, there's a pattern which exists at all. And this is where you would start such a research project. So we're looking to see whether, is there a pattern at all, or a pattern of any kind, in our data? And what would that data pattern look like? And so these are the types of questions that you want to ask. You're really articulating the question. You're really putting something together. So now, going back to my RStudio here, I'm going to go ahead and view my sunspot data here. This is the next line where I am. I'm not actually selecting this time. I don't think I have to select it every time. But I can click on the Run button, and you'll see that the data is now shown to me. And I can now see, like, for instance, what the data is. Now, the data is, and by the way, this is always a very important piece. Whenever you are working with any kind of analytics here, please do spend sufficient time going through your data to really know what's there, because after all, this is where your research is going to come from, by looking at the data. So you have data that starts in the year 1818, and if you go all the way down to the bottom, yes? I can hear someone. Is everything okay?
Professor?
Yes.
Do we have to import the text file or the CSV file?
It's the CSV file. It's the CSV file. So I wish you could see what I see on my screen here. But yes, so Alex, I think that's Alex. I think that's your voice. When you're on this line right here, when you click on, in fact, I can't show you what I see here, but when you click on this line right here, what it's going to do is it's going to ask you now to find the file in your Sandbox, and the file that you're looking for is your what is it? It's in SunSpots, and it's called SunSpots CSV. And so you're looking for that file here. You're looking for this file here. And that should be in your repository, and then in your lessons, and then in your week 3, and then in your Sandbox. Alex, did you find that?
Yeah.
Okay.
I got it.
Okay, good.
Thank you, Professor.
Sure. It's a great question. I mean, there's no such thing as a bad question here. Please ask. I mean, please ask. I mean, this is it's exciting, and we need to. And I don't want to miss anything. I don't want you to miss anything either. So this is the file you're looking for here. I'll just leave this here. You don't actually need. This isn't actually code here, so I'll just comment that out here. But now I'm going back to the code here, and I'll just take you through line by line. I'm up here now. So this is the code that actually loads the data file here. That's your CSV file. Maybe I'll just add that actually to the code so that you can see what it is that this is supposed to do here. Now, the next thing is this line that we just ran here called view sun data here. And what that did was that showed us, if I just go here and I click on run, then it opens up this page here of the data itself. And the data, I'll just take you through the columns here, but the data is the year. It goes from 1818, I think, up to almost present day. And then we have the month, the day, and the fraction of the year. Now, the month, this is a kind of it's a spreadsheet, if you will, but each observation or each row is really information about what kind of sunspots they saw on the first month and the first day. And then they use this information here to calculate what they call the fraction of the year. That is, like, how far into the year are we? It's just something that it's a chronological detail here. And this sunspot number here, where it's -1, I believe that what they mean here is that they didn't see anything, or it wasn't there. And then they also have some built-in macros that when they made this data to compute the standard deviation, the number of observations here, which is 0, they didn't see any sunspots at that day in 1818. And then we have this other thing, I'm not sure what the def indicator is. That must be some internal code that they use, but we won't be using that. You're not always going to know what all the columns are when you're looking at the data, but most of them, though, should be fairly understood. Because when they give you I didn't get a code book for this, but typically though, when you when you get data here, it will come with some kind of a text file or something that would explain to you what each of these columns is. So what really we need to worry about though is that we have this information about the month and the day, and then we have the number of observations. That means that, for instance, as I move down here, I'm going to go down, I see, like, for instance, on the February 9th, there was one observed sunspot, and hopefully you can see where I am. I'm on this line right here. There's one observed sunspot, and as you move down, you start seeing that more and more sunspots are becoming more and more prevalent as the months go on. And so here we are, for instance, already the 7th month here, which is, what is that, August? Right, January, February, March, April, May, June, August. So you can see that if you look at this number of observations here, you can see that they've found more and more of these sunspots as you go down. Now, keep in mind that this data comes from 1818, so that means that somebody was using this data. Somebody's actually recording this data for you. And one thing that we should be careful about is that they may have had different instruments back then. It may have been somebody who was, hopefully he didn't lose, or she didn't lose their sight looking at these sunspots here, but they had probably just a telescope, and so they didn't have the same kind of sophistication that we might expect today. And so if I take you down to the bottom of the data, where we're 2009, that's where I ended up here, you can see, for instance, that there are many, many more observations here. Before we were looking at 1 or 2. Here we see 16 observations for February 8th, 2009. Now that's probably because we have a more advanced system here. But the data is the data, and so we can't go back to 1818 and check out and see what they had. And so I think that in terms of data, it still works out quite well. I hope that person from 1818 didn't succumb to any eye injuries from this. That would just be terrible. Please do not look at the sun. Don't stare directly at the sun. It's very, very dangerous. Okay, so I'm going to go back now to the code here in RStudio. Hope you can see that. There, switch it over. Now, what we're going to do is I want to see what the names are. So here's this other piece of code. I'm right here. And this other code right down here tells us what the columns of the data are. We just looked at the columns here, but this is actually the list of names. You might need this later, so hang on to this code later if you need to know what the columns are as you're doing your analysis. Sometimes it's easier just writing a piece of code like this than having to actually hard code things. But we'll talk about that later on. But the first thing I wanted to do is I wanted to create this plot right here. And so hopefully you can see this plot if I go ahead and just run this. And it's going to show up. Where is it going to show up here? There we go. Okay, it looks a little bit sketchy. No big deals here. But actually, this is, believe it or not, what the data looks like. I think this is just an extraordinary. Every time I look at this plot here, I'm really, it's amazing. Oh, it's just gone. I'm going to try and run this again here just to see if I can get this a bit more clear. There we go. Oops. That's not help now because it's Murphy's Law. The more I need something, the less likely it is to actually show up. Oh my gosh. Anyway, if you run this at home, you should see a similar kind of plot showing up where you have all these, like, what I call, like, teeth. There we go. So what are we looking at now? This is your pattern, right? So what we see now is from the I'm going to the left-hand side of the plot here. On the left-hand side of the plot, from 1818, you can see that going all the way to the right here, we have what I call teeth. 7 different kinds of teeth in the data here. And these are your 11-year cycles. There are 19 of these 11-year cycles here. And you can see that as you go through these 11 years, you start out with a small number of sunspots, which increments all the way to some kind of crescendo, or some kind of middle point, maybe 5.5 years. And then after that point, the numbers begin to subside. And that happens again and again and again and again. Now this is the pattern that you're looking for. This is like one of those patterns that just pops out at you. And when you see this, there's no way to forget it. There's no way to convince yourself that it's all random. There's nothing random about this data at all. So let's go and look at some other things here. Let's do some other plotting things here. And by the way, you don't need to know about what the code is actually doing yet. We will actually explain that next week. These plotting commands here will be all second nature to you in no time at all. But for now, though, let's just look at the results here.
Professor?
Yes, sir.
I tried to run the ggplot and it told me that it could not find the function ggplot.
Did you try?
There was an error.
Did you try? Did you use the command library? Oops. B-I-R-Y. Tidyverse. Did you try? Did you run that?
Yeah. So I was able to install it, but I think I got it now.
So it took the command. The ggplot was recognized, I guess.
Yeah.
Okay.
I think so.
Good.
All right. Thank you for.
You had sure, not a problem. Let me know if there's any problems. Just let me know. Thank you. Okay. So the next thing I wanted to show you though was this is another thing here. So now that we've established that there is a trend that exists in this data, this blue line that we see that goes through this plot is something about, we'll talk about this. This is actually a regression line here. It's actually looking at it's taking all the data and basically kind of squashing it into one little line here. And that one line is then used as a kind of predictor of the events that happen during the course of the data. And so for instance, I'm looking at the first, right over the year like 1860s, 70s in there somewhere. There's a point in my blue line. What that suggests is that the data is actually kind of climbing. There's that the line kind of climbs with the data. And so where the line dips, the data has dipped. And so that's on the data in this sense here. Let's go back to that and see what that is. The data we're looking at is, for instance, the fraction of the year, which is the x, and the y is the number of sunspots that we see here. So really what we're doing is we're going throughout the years of data here, and every time we see a number for a sunspot, that number then becomes plotted on this as the y component on your y-axis here. And so the blue line is just saying that we're finding this. The numbers seem to be going up between 1800s to 1860s. Then it goes down, and then it goes up again, maybe in 1930, and then it eventually subsides in year 2000. So what I'm saying is that there are patterns that we see, which are micro patterns, which are basically these 11-year cycles. But if you zoom out and you have like much more data, which we sadly don't have, you might see that this line, this blue line, also has its own more drawn out patterns. And so there are patterns everywhere that we're looking at here. The next thing I'm going to look at now is I'm up here on line 28, and I'm going to run this and see what I can get. This is taking some time on my machine. I think that my machine's almost maxed out here. Okay, so I'm just adding some color here. Maybe the color is not that useful, or maybe it is, I don't know. But we will go through all this code here. But this is a different way now of visualizing the same thing. Notice we went from black and white, now we're at colors, we have this line, and now we're getting an idea about how things are moving along. And so, for instance, now it's redundant for me to have the 1850, this x-axis line here at the bottom. I don't have to have that here at all, because if you notice that on my, if I can second, but if you look at my legend here, you'll see that as the years become more and more recent, the color gets lighter and lighter. And so you might describe your graph in terms of chronology, and maybe you can use in chronological terms here, but the chronological terms are defined in terms of color. And so here's another way of doing that. Let's move on to another one here. I have in my code here, there is a way of actually saving this particular. If you want to save a plot here, it's only good. I mean, you might want to run something, and then you might want to save your plot here. And so what this is going to do is you have this command here called PNG, which basically establishes a file name, and then it's going to. And then if you run this graphing plot or this plot making function again, it will take whatever is produced here, and then it will save it to this file once this function over here has been invoked. And so I know this sounds like a lot of extra work here, but you build this into your code, and it's always the same code every single time. So let's go to this again here. So this establishes a file name. This actually does the plotting, and then this thing says, okay, whatever the last plot was, save it to this file name and leave it there. And so I think that if I run this code here, then I'll get this file that'll show up. I'm not going to run this because I don't know where this. I don't want to go chasing after this file, but I think that you can always add your own path here, and this will send the file to your temp directory if you're using a Unix machine here. Maybe I can just try that and see what happens here. It's going to take my file and save it to my temp directory, which I see, which is there. So so I have to I can see it there. So the file is actually loaded or actually saved now in this path right here, and then this next part is the file name. Anyway, we will talk about all of these things later. I just want to give you an overview about some of the functionalities that you can do with R. So I don't expect you to start pulling out your hair and worrying about what the code is all doing here. We'll go through all of this code. Don't worry. And then this is another way of these are just other plots that we were looking at earlier that we can plot, and you can save them if you want. There's another command here called ggsave, which essentially does the same thing. I think ggsave is a part of Tidyverse. That's a more recent way of saving plots. But if you're old school like I am, you might use something like this, because this is the actual code that you'd use for our statistic, which has been there for, I think, since almost the beginning. They both work just fine, so you can choose whichever one you want to have here. And so maybe that's just as well. You just choose whatever you like. I'd like to take you now, if I may, we have some 25 minutes here. I'd like to take you into another example of working with data. If there's any questions over this, please ask them now, and then we can handle them, and then I can go into the next thing.
So downloading the Tidyverse thing, you just put libraries, parentheses, Tidyverse.
That's right. So I'll show you. So if you can see my screen now, I'll go down to I'm right down here. So when I want to install the library, okay, I should back up here. If I'm running a brand new install of rStudio, and there are no libraries in the hard drive, there's no code here from libraries, then I'd have to type in this command here called install packages right here, and you have to put tidyverse in quotes, just like that. If you can see that, okay. What that does is it goes out onto the R programming cloud, if you will, and it finds that library by that name, which is called Tidyverse, and it downloads it and installs it on your machine, and then it's there. So that's the only time that you'll really have to use this. Now, if you're using another machine, or if you run a command to try and load your library and it doesn't come up, if it says library not found, then you have to install it. So this is your command that you'd use to install. Now, you'd only run that once, and so you don't need to have this in your code all the time. So what I would do is I'd run it once and then leave it in your code like that, so that if later you come along and you run this thing on a different machine and it doesn't work, you can remind yourself what the command is to actually install that library by doing this. But if you have this hashtag in front of it, it's not going to run. You see how it just ignores it. So the next thing that you have to do is, if you go back to the code itself here, we have the actual library command here, and that's what you have to run every time you run this code here. And that says, okay, go to the hard drive of a local machine and pull out this library called Tidyverse, which should be installed. If it isn't installed, it will complain, and you have to run this up here. And then once that's there, I think that all the other code should be able to run. Keep my fingers crossed here. Does that work?
Yeah, it's installing all the packages.
All right, perfect. Yeah, it may take some time. Sorry about that. It may take some time to install these things here, but once you've installed those packages, it's done, and you never need to do that again on that machine. But if you use a different machine or a different install, or sometimes I think that over the summertime when I reinstalled my my OS on my Mac here, I had to reinstall my libraries, which was kind of annoying. So that's why I keep this. That's why I keep this information kind of listed here, commented out so that I can see it if ever I need to install it later. Okay, so I'm hoping that everything's okay. What I'm going to do now is I want you to go now to. You can't see anytime I touch the menu here, you can't see what I'm doing here. The next thing I want you to do now is to open another file here. If you go back to your repository for your Sandbox, or your Sandbox directory in your repository here, there is a directory called coronavirus analysis. And inside coronavirus analysis, you'll find a data file, which is called coronavirus.rda. And there's another file, .r. That's the .r file is the code, and the RDA file is the data. Now I want you to right-click on this file and to open it in your rStudio. This is actually, I think, a rather important piece of analysis for us. We've all just, we're all going through this pandemic together here, and it's tough, but we'll get through it. Yes, sir. Sorry. There's a question. The folder would be where, if you go back to your, I can't show you what I'm doing here. Go back to your class docs repository, then go into lessons, and then go into week 3, and then go into Sandbox. What do you see in there? Is there a coronavirus? You may need to pull over your repository. Is it? Can you git pull? And yeah, so this is something I put in there just last night. The Sunspot stuff I put in there, I think on Monday or something. Is anything coming over? Let me just take everyone through that. I'll just take a moment here to go back here. Okay, so what I'm going to do is I'm going to go to my terminal, and you'll see here. Hopefully you can all see my terminal. This is where I keep my files. I have repository, then I have my year, I have fall, and then I have, for instance, the class, which is CS301. And then inside that I have class docs. And when you're inside class docs, these are the directories you have. You want to type in git pull, and all files that that you don't have, which are on the cloud, will be pulled over. And this coronavirus data is one of those files. Let me just show you where the file actually would be found here. So if I go into my lessons here, okay, if I go into lessons, I have this week 3 visualizing. Go in there, and inside there you have this. You have your slide that we're running right now today, and then you go into Sandbox. Sir, did you get that to work? It worked. Okay, so it came through. Okay, good. So what I'm asking you to do, though, is to go into this directory here called coronavirus, and there's this file here. You may have to click on things here. Actually, navigate using your Windows or your clickable interface, and then to right-click on this file here, compare countries _17September.r, and load that in your rStudio. Now, this is a rather interesting example here, because we see on the news all the time about the coronavirus, and we're getting through the coronavirus, and it's going to be tough here, but we are getting through it. But every time you see this, the news about it, they're always talking about the like how many infections there are, and what countries are the worst, and all this scary stuff. And so now I'm hoping that this tool here you can use to do your own analysis on what countries have more infections and how those infections are coming along. So let me just take you through this code here. This first line up here, this rm list, it's a pretty crazy looking function here, but what it does is it just goes through and it removes all my environmental variables that I have, that I've already used. You'll notice, for instance, that my plots will stick around. I can remove the current plots here, but the plots will stick around from down in the visuals here, but my environmental variables here are gone. And that's all because of this. This kind of clears out all the variables that you have in memory. And I do this because when you're writing code in R, sometimes you have a variable that you created manually, and that interferes with some of the code that you're running. This might be tricky here because this is another library here. So here's something that we should try here. So again, we have this library here called Tidyverse. I'm going to go ahead and run this. Now, if you run Plotly and you find that you get this error message that says that it's not working, then you have to go back and do the same thing that we did before, which is to type in install packages, and you put in Plotly. You're going to have to run this command here. I can hear somebody. So this is exactly the same problem that we had before. When you're working with a brand new install of rStudio, you have to install these libraries, which is really annoying. So we'll get through them, don't worry. So this install.packages plotly, go ahead and run that. Or you can equally just type that down here and run it if you like here. And then when you run that, it's going to install all the most recent. Oops, I didn't actually click enter here. It's going to install your library that you need here. Did anyone have any trouble with that? Everything okay? Okay. It's all good to go? Okay, it may take some time on certain machines, and so I do apologize for that. But again, just like before, once you have installed this, once you've typed in this command down here, and you've installed your Plotly, then you will never have to do that again. You just have to run this library here. And then that will actually load your library. So I'm going to go ahead and just select this over here. I'll click on Run. And then it runs it loads my libraries, and it runs everything here. But I would really recommend, though, that you keep this hash in front of an install packages command like this, because it's you don't need to reinstall the packages every time you run them. It'll just take time. And so if you run this program like 5 times while you're 5 or 6 times while you're writing it, it will just take ages to install these packages over and over and over again. Now, the next thing I wanted to talk about was, for instance, you have some references here about where this data came from here. The code is, here's some references for the code. That's where the inspiration came from, but some of the code I put together myself. You have the actual data it's to look at right here. And so this is a GitHub repository. And so if you go there, you'll just see it's someone else's repository. They're managing the whole thing here. They collect the data and they leave it on their repository, which means that you can just log into this repository and pick up the data set as you want. And I think that the data is actually quite current. I think it comes through like seemingly all the time. It seems like this data is accurate as of I think last week, and so it's quite nicely curated. Now I have this next piece of code right here where I'm going to be loading the data file. And hopefully that'll be okay here. So first of all, I have to establish what the file is going to be called, which is this corona.rda file. And that file, if you remember, is the file that we have right here. It's this file that's also in our Sandbox repository. You can see my crazy looking, this is extraordinary here. But you can see, for instance, that you have the file is going to be in your Sandbox. Your Sandbox coronavirus analysis, it's in your case, it's going to be this. That's going to be your what do you call it, your path. I can use a file chooser here, and I come prepared here. So this next kind of code here, I'm going to try this. I think this will also work here. So if I run this, for instance, actually I don't need this part, but I can run this line right here called my file. And I'm going to hit return, and this will allow me to actually find the file and pick it out. Hopefully you can't see what I'm doing here. But if I run that, I get a panel where I can actually click on things, and then you can see kind of your files. You can go to your files, and you can see where the pieces are. And I can pick out the coronavirus file. Hopefully that will work. And then if I load this file, it will come up. Okay, so try So in this case, try this code down here. I was hoping this would be a little more simple where you don't have to keep picking out things, but I guess this works just as well. So sorry about that. Now, what this is going to do is this is going now to load this file here. And so if you look at the data up here, if I click on data in the data section on the right-hand side. By the way, did anyone have any trouble when they were finding the file? Did they locate the file? Everyone? Yes, sir. Okay. So it sounds like, could you try running this, just try running it again? Maybe, for instance, I think that the load, if you run both of these lines together, then once you've picked out the file, then it will try and load it. Perhaps you could try running that again and see. Because I think that what the first line does, that my file, this actually returns a string, which is the file name. And then we have this command here called file.choose, which will go through and actually pull out the file. And that's the data file. Do that. So do you see in your data, in your global environments, like for instance, up here, if you click on that, does it show you the data? Like this. Do you see something like that? Even when you have to load my file, is everything uncommented? Is it maybe I'll have a look. We may have to come back to this on next time. I think we'll bring this up on Tuesday here. Maybe since we have 2 weeks or 2 more, we'll just hold on to that question. We can perhaps come together after class and we can discuss that. But let me just show some of the other things here in the last minute or so that we have. We will come back to this before for too long here. But I'm going to run this over here, the unique. This line over here, this will show us what provinces we have in our data. And so, for instance, what we have is the dates and provinces, country, latitude, longitude, type. What kind of confirmation is it? Is it a confirmed COVID-19 infection? And how many cases are there? And so as you move through your data, this is for Afghanistan. I'm going to move through in the middle here someplace. This is Bhutan. You can see, for instance, in Bhutan, you can see how many deaths there were. I guess they had no deaths here. I'm moving around the data here. Here we are. Here's a death in Benin here. You can see, for instance, where the country is located. So that's the map information. You can see how many deaths that they had on that day, which is 1, during the 7th month of the 29th day of 2020 here. So you get the idea that you actually have an exhaustive supply of data that you can actually work with here. This is the British Virgin Islands here. You get some ideas about the dates and things. But let me just go back to the code for a second here. And these lines right here, we'll actually do the analysis, I think, on Tuesday here. But these lines of code here actually show you what countries you have in your data. So this line right here for country, if I run this, I see I have China, Canada, Australia, Zimbabwe, Zambia, Yemen, Western Sahara here, I have Vietnam, United Kingdom. You have all the countries of the world, basically, in this data set here. And in the actual code itself, then, for instance, you can then, what I'm doing here, and in fact, you can run this at home if you'd like. I'll just quickly take you through this. This is for Sweden, where I've actually loaded the data for Sweden, and I am actually making a plot of what Sweden looks like. And so this is what Sweden's infection rates look like. In fact, if you keep on going, I'll just do this quickly here. For France, for instance, this is what France looks like. If you want to look at the US, you can see what the US looks like here. And so you can see, for instance, just by these plots here, this is data, but the data describes an infection. This is Italy. I'm just running this code here. This is what they had in early April, remember that, and late March, where they had this really high amount of infection here, which then kind of topped out. I know we're over time here. Let me just finish this, and then we'll get to the bottom here. But you have this. This is what their infection rate looks like. And then down here at the bottom, for instance, I actually have some code here where you can look at this, run all this code here, and then you can compare, as soon as this thing comes up here, you can compare different countries with each other here. So what I'd like you to do, though, is to take this code back with you and actually look at it and see whether you can kind of modify it and change it, add your own countries. Look at the code itself. Look at how the code has come together here. And that'll help you to kind of to change the analysis. We will be going through this on Tuesday, so don't worry. It should be good to go.